Okay, you know where it's at. So RSTU is a rectangle. We need to prove that the diagonals are congruent. So we are going to start with our 2 columns. So I'm going to write statements and reasons here. No. And I'm going to write my given information. We love to draw in things because through any 2 points there is exactly one line. So we are going to draw in SU and RT. So then we need to see the 2 triangles that are being formed there. So we can use our triangles to prove this. So we have this triangle here and this triangle here that we are trying to prove congruent. Do they share anything? Do they share anything? Yeah, but that's within the triangle, so you don't want to look at that. Do they share any sides? What side has the overlap of highlighting, guys? UT, UT. What is that property when you say UT is congruent to UT? Reflexive. It's like looking in a mirror. What's wrong?
I can't see.
Maybe you should wear your...
Are you okay?
Yeah.
Are you sure?
Yeah.
You want a chair?
Where's your seat at? Over there. Here, sit in my seat. I can see forever.
Oh, I have glasses. Just touching.
Thank you, Kylie.
Yeah, I'll sit down.
I know you did too. So we have the reflexive property because they share this angle here. What's wrong? What were you going to say?
I said never listen to me ever.
But I want to listen to you. Did I not write given in that spot? I just left it blank.
kind of confused. That's actually exactly what I was going to say.
Why? I just looked up there and I was like, what did I do? I wrote the number and then stopped. Okay, what do we know about opposite sides of a rectangle? Opposite sides of a rectangle are? Congruent. So that is a property of rectangles.
Why don't you just put 1 and 2 on the sides?
I don't know. Okay, Greg.
Okay.
RU is congruent to ST. Maybe I just wanted more dashes. I don't know. Opposite sides of a rectangle are congruent.
What is UT with? Because you only got 2 lines.
What?
You only have 2 lines of UT, but not.
Because UT goes with UT.
Oh.
Wait, how does UT go with UT?
Because they overlap. It's reflexive. Do you see how this yellow triangle and this pink triangle both have UT? Do you see how the yellow and the pink are overlapping?
Yeah.
Okay. So far we have 2 pieces of information. What kind of angles are all of the angles in a rectangle? Right angles. That is the definition of a rectangle. So we know RUT and angle STU are right angles. So angle RUT and angle STU are right angles. That is the definition of a rectangle. And we know all right angles are what? Congruent, because they're both 90 degrees. So we can now say that angle RUT is congruent to angle STU because all right angles are congruent. Do we have enough information to prove those triangles are congruent? Do we? Do we have 3 pieces? So triangle RUT is congruent to triangle STU by what? Side, 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 angle, side, angle, side, angle, 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 side. What is it? What is it?
Side and side.
Side, angle, side. The angle's in between them. Good. Which means that we can use CPCTC now to say that these diagonals are congruent. So do you see how RT and SU line up in our triangle congruent statement? RT and SU line up in there. So we can use corresponding parts of congruent triangles are congruent. Okay, questions on that proof? Sometimes, always, nevers are like a much hated thing by students. They're just really confusing. How are you only on step 5?
Well, you see, there was so much that I just started giving up and just was watching.
That's how I am too.
What'd you say?
Said there was just too much writing, so I just gave up and started watching.
Because you didn't want to write the words?
Yeah.
That's how I was the first quarter.
Even when they're
About math
abbreviated,
in
there's
general.
too much.
The amount of laziness some of you have is just amazing to me. Are the following statements sometimes, always, or never true? If it's sometimes or never, we need to prove a counterexample. A rectangle has acute angles. Remember, acute angles means the angles are less than 90. Is that sometimes, always, or never? Never. Why? By definition, all angles in a rectangle are 90 degrees. $90 is not less than 90. So those are not acute. 90 is not smaller than 90. It's the same. If you draw a picture, the picture better be marked. So if you decide to do this with a picture, you have to mark that these are all 90. Do you understand that? Pictures must be marked. If you just draw a picture without markings or any labeling or anything like that, I'm not giving you the points. A parallelogram has one pair of opposite sides congruent. Sometimes, always, or never.
Sometimes.
So, okay, let's think about this. This is a parallelogram. If it's only one set of parallel sides, or is it congruent sides right now? Is that what we're looking at? Congruent sides. So if these two are congruent, then these two get forced to be congruent as well, right? But if I slant these opposite ways, is that a parallelogram anymore? No, that's a trapezoid. So it says sometimes, always, or never. Never. One of the properties of a parallelogram Oh, I'm glad that we figured that out. It also could be a double V depending on how you write your W's, so it can get confusing. A property of a parallelogram is opposite sides are congruent, or is both opposites of opposite sides. A parallelogram has exactly one right angle. That sometimes, always, or never. Because if it has one right angle, then how many right angles is it going to have? If it's a parallelogram and it has exactly one right angle, wouldn't it be all four of them are right angles?
Yep.
Yeah, because consecutive angles are what? Supplementary. So the word, this is what trips it up here, is the exactly one. If it had said that a parallelogram has four right angles, that would be sometimes, right? Because that's when it's a rectangle. Do you guys see that? But since it says exactly one, it's never, because if it has one right angle, it will have four right angles because consecutive angles are supplementary. I don't know. I haven't finished the other ones. The diagonals in a parallelogram are congruent. The diagonals in a parallelogram are congruent. So let's draw some parallelograms. If this is my parallelogram, are these two diagonals the same length? Do they look the same length? No, but if this is my parallelogram, are my diagonals congruent?
Yes.
Yeah, so is that sometimes, always, or never?
Sometimes.
Sometimes, and it's when your parallelogram is a rectangle. The diagonals in a rectangle are congruent. Think about the proof we just did. The diagonals in a rectangle are congruent. Always. We just proved that on the previous slide. A property of a rectangle you're right, but I'm just writing this anyways, is that diagonals are congruent. Now you're paying attention when you don't have to write that much, right? When it's always. That does not even in English sentence there. That diagonal is congruent. What is that?